Hello students, let us do one more question on the Newton-Raphson method. It is of somewhat different kind. The question is, find the iterative formula for finding 1 upon n, right? It means you are giving some real number, capital N, and you have to find its reciprocal for some real number n using Newton-Raphson method. Find the value of, now here in the first part of the question you have to find the iterative formula using Newton-Raphson method, and using this formula which you will derive here, you have to find the value of 1 upon 31 correct to 4 decimal places. It is the second part of the question, right? Now here, find the iterative formula for finding 1 upon n. The problem is to find 1 upon n. So we will start like this. Let x equal to 1 upon n. It further implies n is equal to 1 upon x. It further implies 1 upon x minus n is equal to 0. So we have changed it into an equation. Now let us name this equation. We are considering that the polynomial on the left hand side is equal to fx equal to 0. Then we are using Newton-Raphson method, so we will also need the derivative. So first of all, let us find the derivative also. F dash of x is equal to minus 1 upon x square, because here derivative of 1 upon x is this, and that of capital N is 0 because it behaves like a constant here. Now by Newton-Raphson recursive formula, we are asked to solve this to find the formula using Newton-Raphson method. So first of all, we will write down the Newton-Raphson formula. We know that xk plus 1 is equal to xk minus f at xk upon f dash at xk. It further implies xk plus 1 is equal to xk minus, in place of f at xk, we will write down from here putting x equal to xk. This will be equal to 1 upon xk minus n divided by f dash at xk. F dash at xk will be written from here. F dash at x is equal to minus 1 upon x square. So f dash at xk will be equal to minus 1 upon xk square, like this. It further implies xk plus 1 is equal to, now we will solve this part, xk minus, this will go up, है ना, minus xk square into this. This will give you xk plus minus minus plus xk, only one xk will be left here, then minus minus plus minus minus, n times n into xk square, right? This will be further equal to 2 times of xk minus n into xk square. Xk is common here. We will write it down outside the brackets. Xk into 2 minus nxk. So this formula in the equation number 1 is the required iterative formula for finding the reciprocal of a real number capital N. Now let us see the second part of the question. Second part is what? Find the value of 1 upon 31. In place of n, we are having 31, right? Correct to 4 decimal places. We have to do its solution also. Now, if we are using Newton-Raphson method, all of you know that first of all we should know the initial approximation to the solution, like we did for finding the roots. We had to, first of all, we had to find out the value of x0 or x0. Now here we need to find the value of 1 upon 31, right? So 1 upon 31 is nearly equal to 1 upon 30. We have taken this as 1 upon 30. Why? Because it is nearly equal to that, and 1 upon 3 can be easily evaluated. Value of 1 upon 30 is equal to 0.0334. Okay, there is difference of only 1 unit here in 30 and 31. Right? So we will take this as the 1 upon 30 as x0. This will be taken as x0. Now here what I have written is this, that putting n equal to 31 and k equal to 0 in this equation 1, we get the first approximation to 1 upon n is x1 equal to x0 into 2 minus n. In place of n we are having what? 31 into x0, right? And I have explained is that we will take x0 equal to 0.0334. So substituting all these values in this equation, we get x1 equal to 0.0334 into bracket 2 minus 31 into 0.0334 equal to 0.0321. So this value is the first approximation to what? To the value of 1 upon n, where n is equal to 31. In the similar way, we will find out the second approximation. Second approximation will be given by, in place of k, we will take 1 now. Because x1 is available to us, है ना? First approximation हमारे पास है already. तो आप क्या करोगे? k को 1 पुट करो इस equation में, तो क्या आएगा? x2 is equal to x1, bracket this value, and when we will put these values of x1 like this, it will be 0.03226. Now again we will keep on proceeding, keep on finding the approximations, because the value is not repeated. Okay, approximation is not repeating itself. We reach the third iteration by doing like this. x3 is equal to x2 into this. When we put k equal to 2 here, this will give you 0.03226. So you can see from the second and the third iteration that the approximations are repeating. They have started repeating up to how many places? 1, 2, 3, 4, 5, up to 5 decimal places. So we stop here, but we had to find the answer up to 4 decimal places. So we will give this as the output up to the 4 decimal places. That is 1 upon 31 is approximately equal to 0.0322 up to 4 decimal places. Okay, thank you. Like this, we can deal with this type of different questions also.